Welcome to the world of composites. Composites. A composite material is a material made from two or more constituent materials with significantly different physical or chemical properties that, when combined, produce a material with characteristics different from the individual components. Application. Composites used in aircraft. Fiberglass is the most common composite material used in aircrafts and consists of glass fibers embedded in a resin matrix. Fiberglass was first used in the Boeing 787 passenger jet in the 1950s, where it comprised about 2% of the structure. In over a 10,000-kilometer journey, there will be an approximate fuel saving of 8,660 kilograms with a 20% reduction of empty weight. Automobiles. The automotive industry faces many challenges, including increased global competition, the need for higher performance vehicles, cost reduction, and tighter environmental and safety requirements. Dentistry. Composites have been by far the most successful in dental applications by meeting several stringent design requirements difficult to achieve with homogeneous materials, such as ceramics and metal alloys. Whether it is preparation of crowns, repair of cavities, or entire tooth replacement, it must match the hardness of the opposing tooth and be resistant to wear or fatigue fracture. It must be dimensionally stable and withstand the largely varying thermal stresses in the mouth. It also has to have short processing time and near net shape, and composites fulfills all these requirements. The resin monomer is typically a methocyclate or a urethane dimethacrylate ester derivative such as a bis GMA cured on site by cross-linkers, ultraviolet light or light emitting diodes. Orthopedic. Composite materials have found wide use in orthopedic applications. Common materials for the femoral stem component, such as 316L stainless steel and the COCR alloys, have very high stiffness compared with the bone they replace. This produces adverse bone remodeling and stress shielding, which over the long term leads to reduction in bone mass and implant loosening. Fiber composites can be tailored to match the specific mechanical properties of the adjacent bone. Carbon fiber composites in PEEK peak or polysulfone matrices can be fabricated with required stiffness. Bone cements used to fill the void and improve adhesion between implants and the host bone tissue have been reinforced with various fibers to prevent loosening. Low volume fractions of graphite, carbon, and Kevlar fibers have been added to PMMA matrices to increase fatigue life. In structural engineering, composite construction exists when two different materials are bound together so strongly that they act together as a single unit from a structural point of view. When this occurs, it is called composite action. One common example involves steel beams supporting concrete floor slabs. If the beam is not connected firmly to the slab, then the slab transfers all of its weight to the beam and the slab contributes nothing to the load carrying capacity of the beam. However, if the slab is connected positively to the beam with studs, then a portion of the slab can be assumed to act compositely with the beam. In effect, this composite creates a larger and stronger beam that would be provided by the steel beam alone. The structural engineer may calculate a transformed section as one step in analyzing the load carrying capacity of the composite beam. Architectural aspect. Along with Shanghai and Hong Kong, Dubai is one of the world's cities where some highly unusual buildings are being designed and built. Many of these have curved shapes that are difficult or impossible to realize in heavy building materials like concrete, steel, and glass. Composites, which engineers are using to build spacecraft, sea walls, and car wheels, are now helping architects to make curved and free-form shapes in large buildings in the Middle East. Afin Innovative Structures, based in Dubai, in the United Arab Emirates (UAE), has combined a carbon-filled with Dow Chemicals' Voraforce TF epoxy effusion systems. The company is using the composite material to build non-load bearing structures in projects such as the Yas Mall in Abu Dhabi, UAE, and the Sidra Hospital in Qatar, which are both under construction. The composite reduces weight by 85% and is 1.9 to 2 times the strength. Future. Composites research is attracting grants from governments, manufacturers, and universities. These investments will find new fibers and resins to create even more applications for composites. Environmentally friendly resins will incorporate recycled plastics and bio based polymers. Thank you.